Today we are going to be talking about we are going to be graphing sine and cosine functions. Yesterday we talked about graphing, and we changed the amplitude, and we had the vertical shift, and today we are going to include periods into this. So before, a normal graph falls within a period of 0 to 360 degrees, or 0 to 2 pi. So 2 pi is a normal period of one phase of the graph. So let's go over an example. So let's do our original y equals sine of x here, and from 0 to, so here be 0, this is 1, 2, 3, this is 90 degrees, or pi over 2, 0, pi, 3 pi over 2. So it doesn't 100% cover this graph, our phase, because it should go up to 2 pi, but this will give us a good representation of what we're working with. Remember, sine over x is our y coordinate, so at y, this is 0, 0, 1, 0, negative 1, so negative 1, negative 2, negative 3, and then down here, and it will repeat accordingly. So it kind of looks like this. Well, in terms of our vertical, our periods, these sines of graphs and cosines of graphs, they are representative. They can represent, if you think of sound waves, and when a sound wave is really slow, it's being multiplied by a fractional, anything less than 1, because it's decreasing the frequency. So when it goes really slow, you sound like this, and you're increasing the amount of periods because it takes longer to say it. Whereas if you increase it by a number larger than 1, you sound like this, and you might even sound like a chipmunk, and you're going quicker. Everything is condensed a lot quicker, or quickly. So let's do an example. So let's say we have y equals sine of 2x. Okay, so we have sine of 2x. Everything, our amplitude is going to be the same. Our vertical shift, see, the amplitude is going to be 1. Our vertical shift, well, there isn't any, but our period now, since everything is being multiplied by 2, our period, which was originally 2 pi, we take our 2 pi and we'll divide that by 2. So our entire period is now in pi. Everything gets condensed in 180 degrees. And in order to graph this, I'm going to take anything and divide it by 2 also. So my point that was originally supposed to be at 90 degrees is going to be at 45 degrees. Up here, whatever it's supposed to be at pi should be at 90, and so on. And so on. So now this is there. So this is trying to 90, 80, 0 will still be 0. What originally should be at pi should be there. Oh, okay. trying to make this here, here, here. And let's connect this. And this is our sine of 2x. Let's do another example here. Let's do a radical example. Let's do the original y equals cosine of x. So let's draw that for reference. So we have 1, 2, 3, -1, -2, -3, pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2. Let's drastically change this. Well, let's change vertical shift, amplitude. So let's say our new one is y equals, let's say -2 cosine of x, cosine of 3x plus 1. Okay, so there's a lot going on there. This one, it has a vertical shift of 1. The amplitude is what, 2? And it's -2, so it's flipped upside down. And the period now is 2 pi over 3. You take that 2 pi, you divide it by whatever is multiplying the x. Let's start off with the vertical shift. It vertical shifts up to 1. So I'm going to take and draw a new point, a new axis for me to work with. So this is my vertical shift of 1. Let's focus. Let's start with the regular y equals cosine of x. So let me draw that so you know what that is. We have here, right, 1 at 0, x is 1, and then that, and then that, and that goes in a pattern like so. So it kind of looks like that. Now it's going up 1. My amplitudes, my periods is now 2 pi over 3. I'm going to draw new benchmarks to where I want to have that. So every marker that I originally would have put it in, I just divide that by 3. So instead of putting it at 90 degrees, I want it at 30 degrees, right? This half of 90 is 45, so it's going to be here. So 0 is still going to be 0. And the amplitude is twice of that. So instead of going up 1, I'm going to go up 2. And then that would be another point. And then instead of 180 degrees or pi, divide that by 3, that's 60 degrees. 60 degrees is not quite 90, more than 45. So I'll just mark that over here. And amplitude is going to be -2. So I want it down, way down here. The next one is 3 pi over 2. Well, 3 pi over 2 divided by 3, that's pi over 2. So that is easy. That goes there. And then the next one would be 2 pi. 2 pi, that's 360 degrees. 360 degrees divided by 3. That gives me 120 degrees. 120 degrees is a little... it's not quite 135 degrees. It's kind of up. If I have to try to figure that out, it is kind of up here. let's see if I connect what I try connect what I have already. So then it's gonna be up here, and then that is one whole sequence. So if I keep repeating this in this manner, thinks it should kind of look like this. Try to not going to be 100% accurate for the rest of this way, but I just kind of want to give you an idea what it should kind of look like. So this is, oh my goodness, this is positive. If I wanted to do a negative, then I needed to flip it upside down. I'll draw that in red right here. So then the negative would have been, draw that in red. That would have been the flipped upside down version of that, like so. So there you go. You have the two different types. So that the blue one was the positive, and that one would have been the negative 2 cosine of 3x plus 1.